Hi friends! Today we're going to talk about greatest common factor. So first let's think about what it means. Well, a factor are numbers that multiply together to make a product. Common means we're looking at something both of these numbers have, and greatest is the largest one. So let's actually do a problem. We're going to use the list method to solve this problem. So first I like to write the numbers next to each other. Oops. Let's erase that. That should be 16. Okay, so now we want to list all of the factor pairs that make up these values. So let's think. Something times something has to equal 12. So I know 1 times 12, I know 2 times 6, and I know 3 times 4. That's it for 12. Now let's do 16. I know 1 times 16, 2 times 8, and 4 times 4. Now that I've listed out all of the factors, remember I'm trying to find the greatest common. So what's the biggest factor we see on both sides that's the same? Well, I see 2 and 2, but that's not the biggest one. I see 1 and 1, but that's not the biggest one. So let's circle up 4, because 4 is on this side, and there's a 4 on this side. So my answer, what is the greatest common factor? My answer is 4. Now let's look at another method to solve. This is called the cake method. You may have learned this when we did prime factorization. So I'm going to start by listing the two values that I have, 24 and 30. I'm going to put them kind of close together, and I'm going to draw the first layer of my cake. I treat this the same way that I did prime factorization. I need to ask myself, what can I divide both numbers by? And try and start small with prime numbers like 2, 3, 5, 7, etc. Well, by looking, I noticed both these numbers are even, so I can divide by 2. So I'm going to divide out by 2 and write my answer underneath. 24 divided by 2 is 12. 30 divided by 2 is 15. And I'm going to circle up my prime number that I divided both of these values by and draw my next layer. Then I'm going to start over and ask myself the same question. What can I divide both of these numbers by? Well, not 2 anymore because 15 is odd, but I can divide by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. And then I draw my last layer. So looking at 4 and 5, can I divide 4 and 5 by 2 or 3 or 5? Not really. They don't have anything else in common. So I'm going to stop there. Now the last thing that I get to do is circle up all of the values that I have divided by. All these small numbers on the side get multiplied together. So this becomes 2 times 3, which of course is 6. So my answer is 6 is the greatest common factor. Let's do one final problem. For this, I want to go back to using the list method. So I'm going to write down all of the values of all the factors of 20 and all of the factors of 3. Well, 3 is easy. It's only 1 times 3 because it's prime. Now let's do 20. 1 times 20, 2 times 10, and 4 times 5. So as I'm looking at these numbers, I'm noticing, well, they don't have a lot in common, but they still have one thing in common, and that's the number 1. So when we are doing numbers that don't have anything else, you can still list 1 as the greatest common factor. So in this case, my greatest common factor is 1.